Yes, that is, let's take an example. What is speed? Speed is distance traveled by. What is speed? Speed is distance traveled by time taken, right? Mm. Speed is distance traveled by time taken, S by d by t, right? So let us assume distance is x and time is t. So what is velocity? Velocity is a scalar form, right? So if you have difference in the distance traveled as dx and difference in the time taken is dt, this is dx by dt. What is dx by dt? The dx by dt is nothing but what? Rate of change of distance. Okay, this is one order. We are differentiating with respect to x with respect to t. What is velocity? Velocity is nothing but rate of change of distance, right? And there is another term called acceleration. What is acceleration? That is also a velocity. There's also a vector which is rate of change of velocity. That means I have to differentiate this further, right? D by d of dx by dt. This is called second order. So we generally write it as d square x by dt square. So this is one of the practical aspect of second order derivative. Okay, there are many such things. You will understand the many more practical examples in the next class, that is tomorrow's class, where we are discussing application of derivatives. Okay, so right now just have to understand second order derivatives. You have to differentiate more than once successfully. If you differentiate one more time, that becomes second order derivative. Okay, so let me go to some of the solved examples, shall we? Yes. So there is an example here. Y is equal to simply 6x cube minus 9x square minus 3x. So I want to find the second order derivative. First order derivative is differentiate first one time with respect to x. We end up with 18x square minus 18x minus 3. Differentiate with respect to x again. That is when we get d square y by dx square. So multiple way to represent this. We can even use y1 for first order derivative, y2 for second order derivative. There is also another way, f of x. First, if we differentiate, it is f dash of x. Double derivative, we can use this symbol as well. Okay, just be noted. Just remember this. So when you differentiate this further, 18 to 36x minus 18. Let's see the application in the next class. First, for now, we are going to take this method to differentiate twice, that is second order derivative. So let us look at another example. Y is equal to, how do we have? E power 6x into cos 3x. So how do you differentiate one time dy by dx is equal to what? So we are going to use a product rule. Let's keep e power 6x as it is. Cos 3x is minus sin 3x into 3 plus, I'm going to differentiate now e power 6x. That is e power 6x into, what is it? 6. So before differentiating this, let's take common things, whichever is common here. 3 is common, e power 6x is common. I end up with minus sin 3x plus 2 cos 3x. If you differentiate further, one more time, d square y by dx square, we end up with another term. So if you want to simplify this term, we can, let's see the steps directly. As I don't have space to show this here, let me show you the steps directly. Yeah. So this takes a longer time. So I'm just explaining this directly here. So first we did with the product tool, this is what we got, right? After that, they have taken e power 6x, which is a common value here, minus sin 3x plus 3. Okay, so e power 6x is taken common. So we are ending up with only this part. So d by dx of e power 6x for the differentiation. So when you differentiate this, e power 6x is kept as it is. They have differentiated this using product rule, and then they kept this function as it is, differentiated e power 6x. So when you simplify further, e power 6x as it is, when you differentiate this, minus 3 cos 3x into 3, minus 6, because differentiation of cos 3x is minus sin 3x into 3, and this part minus 3, the function is kept as it is, differentiating this e power 6 into 6. So finally, again, e power 6x is common. They've taken it outside. Finally, what we end up with is 6 minus 6 sin 3x and then minus 3 sin 3x, which and it has been multiplied, right? When you multiply all of them, we get minus 9 cos 3x minus 18 sin 3x minus 18 3 sin 3x and then 3 power 6 cos 3x. So further, all this has been simplified, and finally this is the expression we have got. So let us look into some example better and we will solve it ourselves, right? Yes. What do we have is, we have to find the double differentiation of this particular question, which is y is equal to x power 4 plus 3x cube plus 2x square. So one time if you differentiate, we get 4x cube plus 3 3s are 9x square plus 4x. If you want to differentiate one more time with respect to x, this is what we get, 12x plus 12x square plus 18x plus 4. This is our answer, right? Quickly going to the next question. Let's finish it off and we'll be done with the differentiation, second part of continuity and differentiability. So y is given as sine of what? Log x. Yes. So if you want to differentiate one time with the chain rule, this is cos of log x into 1 by x, right? So now it becomes cos of log x by x. Now if you want to differentiate one more time, we have to apply quotient rule, which is 1 into cos log x minus x into minus of sine x, sine of log x, yes, am I right, into 1 by x divided by x square. This x cancels. We end up with cos log x plus sine log x divided by, yes, with a bracket please, x square. Let's see the answer. See, that's what they have got. Minus sine log x plus cos log x. Minus is taken outside by x square. Okay. So next question, please. We have to differentiate with respect to t here. Double differentiation they're asking. So what is it? X is given as a cos 4t plus b sine 4t. Differentiate with respect to t once first properly. If you differentiate, a remains as it is, cos 4t will become minus sine 4t, okay, into 4 plus b as it is, sine 4t differentiated is cos 4t into 4. So let us take this 4 outside. It is minus a sine 4t, right, plus b cos 4t because we have taken 4 outside. So we'll differentiate this again with respect to x, d square x by dt square. Slowly, we'll take the 4 outside. This is a very interesting question. Now minus, if you differentiate again, you'll get the same function with a minus sign. Minus a cos 4t into 4 plus again minus b into sine 4t into 4. See how this is giving you the function back, right? I'll take 4 as well as minus 4 outside. I end up with given function a cos 4t plus b sine 4t. I will take minus 16 into the given function is what? X. So isn't it equal to minus 16x? Yes. Which option? Option D. So it gives back the same function because this function is designed in such a way that after double derivative, we're getting the function back with a minus 16 multiplied to that. Okay.